Today, we are cracking the code on something really cool, thinking skills. We're going to break down what they are, see how they're tested, and most importantly, explore how you can actually get better at them.
So just imagine for a second, a test where it doesn't matter how many facts you've memorized. A test where it's all about your ability to reason, to figure things out, and to solve problems you've literally never seen before. And that right there is the whole point of these thinking skills assessments.
All right, so here's our game plan. First, we'll get a handle on what these skills even are. Then, we're going to dive into 3 key types: logic puzzles, spotting bad arguments, and then thinking with shapes and numbers. And we'll wrap it all up with how you can actually train your brain to sharpen all of this. So, what are we really talking about when we say thinking skills? Well, this isn't your typical school subject. This is about the actual machinery of your mind. You know, how you take in information, play with it, and come up with solutions. And a perfect real-world example of this is the Opportunity Placement Test in New South Wales, which is actually where all our examples are coming from today. These kinds of programs are specifically looking for students who can think on their feet, who are critical and creative. They're trying to measure your raw problem-solving horsepower, not just the size of your mental library. Let's start with a total classic, logical deduction. I want you to think of yourself as a detective, okay? You get a file with a bunch of clues, and your job is to systematically work through them until you've cornered the one and only correct answer. It's all about having a process. Okay, here's a pretty straightforward puzzle to get us started. We've got 3 people, a list of their pets, and the mission is simple: figure out which pets belong only to Alex. Now, at first glance, it might look like a messy jumble of information, right? But with a clear method, it's actually pretty easy. And this is where this system just works. It's beautiful. First, you just list out everything Alex has. Simple. Then you go down the list and cross off anything that Ben also has. So goodbye frogs and rats. Then you do the exact same thing for Carlos's pets. Bye-bye fish, rats, and frogs. And what are you left with? Snakes and lizards. See? No guesswork, just pure, clean, step-by-step logic. Okay, you ready to level up? This next one's a little trickier. The last puzzle was all about elimination, but this one is about juggling multiple possibilities at once. It's a spatial reasoning puzzle. We know 3 people are in a row, but we don't know the exact order. The trick is to hold all the possible arrangements in your mind and see what they all have in common. Now check this out. The first clue says Archie is to the right of Bo. So what does that actually tell us? Well, it doesn't lock them into specific spots. It just means that wherever they are, Bo is somewhere to Archie's left. So that gives us 2 main possibilities to start with. Okay, now we layer in the second clue. Carter is to the left of Archie. So just like Bo, Carter also has to be on Archie's left. When we combine that with our first 2 scenarios, we can actually narrow things down quite a bit. Suddenly, we're only left with 2 possible ways these 3 can be standing. And here's the magic trick. The question isn't what's the order. The key is finding out what's true in every possible scenario. And if you look closely, in both of our valid options, who's always on the far right? It's Archie. Every single time. So we've solved it. He has to be on the right. All right, next up is a skill you will use every single day: critical reasoning. This is all about finding the weak link in a chain of logic. You know, spotting those flawed assumptions and those giant logical leaps people make. So let's look at this situation. A teacher, Miss Chen, she notices a trend. Most of the girls want to watch one movie, and most of the boys want to watch another. And from that, she jumps to a pretty big conclusion about how to split up the entire class. It kind of sounds efficient, but there's a huge flaw in her thinking. Before I tell you, just take a second. Can you spot it? Where does her logic fall apart? This is exactly what critical thinking is. It's that moment where you pause and you question the bridge between the evidence and the conclusion. And there it is. The mistake is so simple but so common. She's confusing most with all. Her evidence is about a majority, right? But her solution treats these groups as if they're 100% identical. She's completely ignoring the girls who might be huge Star Wars fans and the boys who'd rather watch Harry Potter. Spotting that kind of flawed jump is a huge part of this skill set. Okay, time to switch gears. Now we're going to get into problems that you have to see in your mind's eye or solve with a bit of number logic. This is where spatial and numerical reasoning really shine. So here's a classic spatial puzzle. You're given these flat paper patterns. They're called nets. And the question is, which one of these can you actually fold up into a standard dice? You literally have to try and fold these shapes in your head and see if they make a proper cube.
But wait, there's a hidden layer of logic here. It's not just any cube, it's a standard dice. And that comes with a very specific rule. Opposite faces have to add up to 7. So 1 is always opposite 6, 2 is always opposite 5, and so on. That's the key.
So armed with that rule, we can go through and test each net. As you mentally fold it, you check the pairs. Does 1 end up opposite 6? Does 4 end up opposite 3? And it turns out this is the only one where all the pairs work out perfectly. It's a cool mix of visualizing something in 3D and applying a strict logical rule. And now for some numerical reasoning. Don't worry, this isn't about crazy advanced math. It's all about using numbers in a logical way to solve a puzzle. So take this problem about 2 trains. A slow one takes 6 hours, an express train is 4 times faster. The question is, when did the express train have to leave?
Once again, the secret is just to break it down. First things first, the slow train's journey is 6 hours long. Okay, if the express train is 4 times faster, its journey is going to take 1/4 of that time. So 6 hours divided by 4 gives us 1.5 hours. Simple enough. Since we know they both arrive at 7 p.m., we just have to work backward. 7 o'clock minus 1.5 hours gets us 5:30 p.m. Done.
So we've seen all these skills in action. But you know what? Here is the single most important thing I'm going to say today. These abilities are not fixed. You're not just born with it. Science shows our brains are incredibly flexible. The skills we just went through are like muscles, and you can absolutely make them stronger with practice.
So how do you actually train? Well, it's about turning these processes into habits. When you read an article, don't just soak it in. Actively hunt for the author's hidden assumption, just like we did with Miss Chen. When you're facing a complicated task, visualize the steps in your mind, like folding that dice. Get in the habit of breaking down any number problem, whether it's a bill or a budget, into smaller, logical pieces, like the train problem. It's those little, consistent actions that build really powerful thinking skills over time.
So I want to leave you with this final thought, because honestly, this stuff is so much bigger than any test. It's really about thinking clearly. So how might becoming a better detective, a sharper critic, and a more creative problem solver, how could that change the way you see and navigate your own world? Something to think about. Thanks for joining me.